Assalamualaikum and good evening to those who are watching this video. So today we are going to presenting about safety interlock system in the petrochemical industry. So let's get started. Before we start, let me introduce you to our group member. So we have me, Ahmad Azrin bin Kamaluddin, one Ahmad Hakim bin Wan Hamka, and also Layman Joshua. And this is what we are going to be presenting about today. So, what is a safety interlock system? A safety interlock system is an automated mechanism designed to prevent dangerous or unsafe conditions by controlling the sequence and operation of equipment in a plant. The main purpose of safety interlock system is to ensure safety, prevent accident, and protect asset by ensuring that certain action cannot occur under unsafe conditions. Why are safety interlock important? First, risk prevention. Safety interlock prevent human error, system failure, and equipment malfunction that could lead to hazardous situations. Secondly, it is because of the safety standard. Many regulatory bodies, such as OSHA, require petrochemical plants to implement safety systems to prevent accident and ensure worker safety. Third, it is to protect personnel and environment. Safety interlock systems help to avoid harmful exposure, such as explosion and environmental damage. Lastly, it is to minimizing downtime. Safety interlock system can automatically shut down or isolate section of a plant before damage occur, which minimize the damage and repair costs.
Thanks to Akmal. Okay. To the next slide is type of safety interlock system. Okay. For my slide is mechanical interlocks. First point is physical barrier or lock that prevent certain equipment from being operated simultaneously, such as valve or switch. For point number two, example, two valve controlling that flow of hazard chemical that cannot open simultaneously to prevent cross-contamination or leakage. For the next slide is electrical interlock. Control system that use sensor, switch, or relay to prevent the operation of equipment unless specific conditions are met. Example, a pump interlock that prevent from starting if a safety limit such as temperature or pressure is exceeded. For the next slide is instrumental interlock. For the first point is safety control based on real-time process monitoring the pressure level flow that trigger automatically action. For example, pressure sensor triggering the closure of a valve if a certain pressure threshold is exceeded to avoid overpressure. Okay, for the next slide, I will pass it to Lemon Joshua.
Thank you, Akim. For the next slide is emergency shutdown or ESD system, a critical interlock system that automatically initiates a shutdown sequence during emergency, fire, gas leak, or overpressure. For example, in case of a gas leak detected by sensors, the ESD system can isolate the affected area and shut down equipment to prevent further risk. For the next slide is example of interlock system in practice. A gas leak is detected in a processing unit handling flammable gases. For the first one, the interlock system will automatically triggers. Next, isolate of the affected area by closing isolate valve. The third one is activation of fire suppression systems. The fourth is initiation of a full plant shutdown if necessary. The system prevents the spread of the gas and mitigates the risk of fire or explosion. Next is advantage and disadvantage of safety interlock system. Number one is prevent equipment damage. By ensuring that equipment operates within safety parameters, interlock system reduce the risk of damage and costly repairs. Number two, improves plant safety. Protect workers and the environment by preventing hazardous conditions. Number three is regulatory compliance. Help help the facility meet safety standards and avoid penalties or shutdowns from regulatory authorities. Number four is operational efficiency. Minimize unplanned downtime and improves the overall reliability of the plant by preventing avoidable incidents. Next is system complexity. Implementing interlock system requires careful design, integration with existing control system, and rigorous testing. Next, false alarm. False alarm. Overly sensitive interlocks may lead to frequent shutdown or alarms, causing unnecessary downtime. Next, human factors. Operators training is crucial to ensure that interlocks are properly understood and maintained. Human error can occur if operators override interlock system inappropriately. Costs. Installation and maintenance of safety interlock systems can be costly, but this is often outweighed by the long-term benefits of preventing accidents and ensuring safety. For the conclusion, safety interlock systems are essential in the petrochemical industry for preventing hazardous situations and ensuring the safety operation of complex processes. They play a critical role in protecting personnel, minimizing environmental impacts, and maintaining operational integrity. That's all from our group. Thank you.